Welcome back to Applied Physics Lecture Series, Unit 2, Semiconductor Physics, Lecture 9, Construction and Operation of NPN and PNP transistors in the common base configuration. This is also known as BJT. What is a transistor? We know already diodes. We are using the word PN junction diode, GNR diode. Diode means simply it is having di means two votes, two electrodes. One is anode and second one is cathode. That's why we know the meaning of the word diode. Now transistor. Basically transistor consists of three legs, usually called as emitter, base and collector. This is the simplest way to remember what is meant by transistor. But if we want to define exactly, a transistor is a semiconductor device consists of three regions. One is emitter, second one is base, and last one is collector. The three regions are separated by two PN junction diodes. Usually transistors are of two types. One is NPN transistor, second one is PNP transistor. So NPN, PNP transistors. That means another way of defining a transistor or BJT, bipolar junction transistor, is nothing but, so one type of semiconductor is sandwiched between the second type of semiconductor. That means if you consider NPN transistor, P is one type of a semiconductor which is present at the middle. On both sides, two N-type semiconductors will be there. Like that, PNP also. Here in case of BJT or in a transistor, both electrons and holes, we are having two types of charge carriers in semiconductors. That's why both electrons and holes are involved in the current flow through an NPN or PNP transistor, and hence it is called as bipolar junction transistor. Already I mentioned, so it consists of three regions. Usually left hand side portion is called as emitter and middle portion is base and right hand side portion is collector. So if you consider the first or left hand side portion, which is called as emitter, which is heavily doped, and the basic work of this one is it injects electrons. It produces more and more number of charge carriers, and it is those charge carriers are transferred to the base. And the middle region is base region, which is very thin and it is lightly doped. So the main function of base is it transfers the charge carriers from emitter to the collector. That means charge carriers are transferred to the collector via base region. And the right hand side portion, which is large in area, is known as a collector, which is moderately doping. That means the doping level is in between heavy doping of emitter and light doping of base region. And the main function of collector is it has to collect the charge carriers from the emitter region via base. So collector collects the electrons from base, it dissipates a lot of heat, hence it is the largest of the three regions. The transistor has two junctions. So usually the first, if we consider the NPN transistor, NP is one junction and PN is another junction. That's why the first junction is similar to the emitter base diode and the second junction is similar to the collector base diode. That's why the transistor is usually having two junctions. One junction is between emitter and base called as emitter base junction or simply emitter base diode. And other junction is in between base and the collector called as common base junction or common base diode. And the arrow represents in between the base and emitter. This is the direction of the arrow is the direction of flow of conventional current. If we consider the NPN transistor, here the arrow points towards emitter from the base, but the conventional current is flowing from emitter to base. Always the direction of arrow exactly opposite to the direction of arrow conventional current flow will take place. As a result, conventional current direction is opposite to the direction of flow of electrons. If you consider the NPN transistor, that arrow points from base to emitter. That means current flows from emitter to base. In the same way, in PNP transistor, the arrow points from emitter to base. That means collector flows from base. Current direction is exactly same because holes are moving in the direction of external field. And biasing a transistor. So if you consider the biasing of a transistor, already I mentioned two diodes or two junctions are there, emitter base and collector base diodes. So both emitter and collector base diodes are operating the forward bias. Maximum amount of current we are getting, that's why we are reaching to the stage of saturation. And second region is nothing but cutoff region. Here both the emitter base junction and collector base junction are operating the reverse bias. Very nominal amount of current will be flowing, that's why it is a cutoff region. And if emitter base junction is operating the reverse bias and collector base junction is operating the forward bias, it is the inverted mode. What is meant by inverted mode? If you know the normal mode or active mode, so then you will know the meaning of inverted mode. What is meant by active mode or normal mode? If an emitter base junction is operating the forward bias, collector base junction is operating the reverse bias, then significant amount of current will be flowing. So such a mode of operation will be called as active mode of operation. Opposite to that of active mode of operation, that is emitter base junction is in the reverse bias, collector base junction is in the forward bias, that is called as inverted mode of operation. And here we have to operate either NPN or PNP transistor in three configurations. One is common base configuration, second one is common emitter configuration, and third one is common collector configuration. Already I mentioned, so the transistor is a combination of two diodes. Diode means we have two terminals. Combination of two diodes means we need four terminals, two for input and two for output. But here the transistor is having only three terminals. That's why I have to make one terminal as common for input circuit and output circuit. That means one terminal is common for emitter based diode and collector based diode. So that is the meaning of, if you make the base as common for both the circuits, common base. If emitter is common between the two diodes, common emitter. If collector is common between the two diodes, common collector. Now we will see the working of NPN transistor under common base configuration. Under common base configuration. So the emitter base junction of a transistor is forward biased and the collector base junction is reverse biased. That means active mode or normal mode. Already I mentioned emitter is heavily doped. As a result, the forward bias causes the electrons in the n-type emitter to flow towards the base. This constitutes the emitter current IE. You can able to see this here. As the electrons flow through the p-type base, they tend to combine with holes. So at the base, the base is lightly doped and it is very thin. Therefore, very few number of electrons are recombined with holes and they constitute a base current IP. The electrons which combine with holes become valence electrons. So these valence electrons flow down through the holes and into the external base lead. This constitutes a base current IP. So the remainder, that means 95% of charge carriers cross over into the collector region via base from the emitter to constitute a collector current, which is represented with IC. In this way, almost the entire emitter current flows in the collector circuit. So that means the emitter current is the sum of collector and base currents. You can able to see all this in this circuit diagram. Large amount of heat is produced in the collector and hence to dissipate the heat, the collector region is made large. The ratio of number of electrons arriving at the collector to the number of electrons emitted by the emitter is called as base transportation factor or base transportation ratio, which is represented with beta. Typically it is around 0.995. That means all the charge carriers which are generated by the emitter are reached to the collector region. Then if you consider the working of NPN transistor under common bias configuration. So all the details are present in the circuit diagram, and if you consider the working, the emitter base junction of a transistor is forward biased, whereas collector base diode is reverse biased. Again, this is a normal mode or active mode of operation. As usual, emitter is heavily doped. Forward bias voltage VEB is small when compared to the reverse bias voltage VCB. When forward bias is applied across the heavily doped emitter, the majority charge carriers, here holes, are moved towards the base. So this causes the emitter current IE. The holes enter into the base. So here base is n-type semiconductor and combine with electrons. The base is very thin and it is lightly doped, due to which only few holes are recombined with electrons in the base region. The remainder, that means more than 95% of holes cross and reach to the collector region to constitute the collector current IC. In this way, almost the entire emitter current flows in the collector circuit. The reverse bias potential of the collector region causes the high attractive force on the holes reaching the collector junction. So as a result, thus the holes are attracted or collected at the collector. So current conduction within the PNP transistor is by holes. However, in the external connecting wires, still the current is due to electrons. So the total emitter current IE is equals to sum of base current plus collector current. Thanks for watching.